Hello, my name is Craig Savage, but you can call me Doc, and welcome to another episode of Real World Analytics or What Schools Don't Teach You. If you've seen my FAQ, there's a number of topics I want to cover in this series, and today I want to talk about ways of thinking. In my opinion, when you're studying something and you're gaining knowledge, you're not only gaining that knowledge, but you're also training your brain to view things in a certain way. And so today I want to talk about different ways of thinking as a student or in academia versus as an employee in industry. This is primarily aimed at undergraduate students. So how do you think as an undergraduate student? What's important to you? The first thing you may think about is, well, I'm in school and I want to get good grades. I want to get good marks. You may be concerned about tuition. How are you affording school? If you live in a socialist country where this is paid for you, fine, you can worry about taxes later. But otherwise, are you on a scholarship? Do you have student loans? Are you working? How are you paying for your knowledge? And then there's extracurricular activities. Are you part of sports teams, political organizations? Do you live on campus with your fellow students? If you're taking online classes, perhaps that's less directly tied to your education experience, but still hopefully you have an outside life and there are other things you do in addition to studying. So if you make that transition from being a student to being an employee, what might be important to you then? Well, the first thing you may think about is salary. This is kind of in reverse to tuition, where if you're at university, you're thinking about how are you going to afford it, how are you going to pay for it. But then when you get to industry and you get a job, you start to get money in rather than having money go out. And so there's a little transition there from thinking about what you're paying to what you're earning. Then similar to extracurricular activities, you get this work-life balance. How much are you working? How much do you have in your outside life? And at university, those two things can blend together a bit, where you have classes and stuff, but then you're also surrounded by fellow students and fellow like-minded people. And when you move to industry, suddenly those become your work colleagues that you might not have the same relationship with. You might not all be in the same class. You might not all be on the same team. But this transition from your interpersonal communications between being in a university or school environment to being in a work environment. And then you may ask, well, what's important to the industry? And at the end of the day, businesses want you to get the job done. So why are there different ways of thinking as a student versus as an analytics professional? So first of all, in academia, teachers are experts. They provide all the information. They deliver lectures. They provide course notes. There's a textbook. You can go to them for help during office hours, etc. Teachers then assess you, normally based on some exams, projects, etc., and you get a mark or a grade. And there's a progression path. So if you want a certain degree, there's a curriculum you need to complete to achieve that degree. From that curriculum, you can go and take all of the classes, fulfill the needs of the curriculum, and earn your degree. And if you change your degree, if you want to add a second degree and double major, you want to add a minor, there are rules to do that. And you complete those classes, and you can get enhanced benefits. Multiple degrees, higher degrees, degrees with honors, etc. Unfortunately, none of these apply in industry. Your supervisor might not understand what you're doing. Currently, I work in analytics, primarily using R. My boss doesn't understand R. And while you get a mark or a grade in academia, employee ratings at large organizations, Dilbert writes about these things for a reason. It becomes very difficult to assign a rating for each employee. And furthermore, if you have a lot of employees, if you've worked on, say, a group work at school, there's a group project and one person in the group isn't very good, hopefully that person is not you. Frequently it's, well, everyone on the same team is getting the same grade. And to a certain extent, large organizations are like this, where you have a team of people all working toward the same goal, and if the goal is reached, maybe one of the people is clearly MVP relative to the others, often not. But if your supervisor doesn't really understand the nuts and bolts of what you're doing, then it becomes very difficult for them to give an objective rating to every employee. And so this becomes very difficult. And progression paths are unclear. While you may say, I complete all these classes, therefore I've earned a degree, if you want a promotion, it's not always obvious how to do that. For one thing, if I'm in a team with 5 people and we have one manager, well, so long as that manager's there, no one's going to take the manager's job. If the manager leaves, well, then the 5 of us might have a bit of a competition for it, or someone might come in from the outside. In in teaching classes, I've mentioned to my class that if you do everything that's asked of you, that's average. That means you keep your job. That means you don't get fired. It doesn't mean you complete everything, you get full marks, you get an A, you're moving to the top of the class, everything's great. So these assessment techniques are quite different between academia and industry. So how can you change your ways of thinking to think less like a student and more like a data analyst professional? So my first recommendation is to try to move away from metrics. Focus less on your grades or marks, and focus more on learning and applying your knowledge. Yes, I know you've probably drilled into that your grade point average or your honors level or whatever is the most important, but if I were interviewing you for a job, I wouldn't even look. I wouldn't really care what university you've come to. I wouldn't care which classes you had. I'm going to present to you a problem and see how you solve it. Now, getting good grades may increase the chance that your CV is shown to me and you come for an interview in the first place, but once you get to the interview, all those grades, I'm not even going to look. And as you're going through school, you're learning things about efficiency, you're learning time management, and so don't overlook these skills that you're gaining, because frequently if you look at job ads, it'll say able to prioritize multiple different projects, able to efficiently manage their time. And if you consider taking multiple classes at once, when you're in an interview, you can say, I had these classes, I had stronger classes, I had weaker classes, and I learned how to divide my time to give more attention to the places where I was struggling, and that helped me to fulfill the needs to graduate. So don't overlook these types of skills when you're talking to potential employers and when you're going forward to interviews. And there's many different frames from which you can approach your way of thinking. If you're doing data analysis, which do you prefer? Do you prefer doing the programming? Do you prefer presenting the results? Do you like to do some of both, or are you tipped one way or the other? To look at a different frame, do you like dealing with data and cutting and slicing and dicing data and looking at it from different angles? Or do you prefer taking some input data and running some algorithm on it to get some prediction, some classification, some ranking? What is it about your current analysis tasks that you prefer? And why do you like it? Frequently in school, people like certain classes because of the teacher. And so maybe the subject that you're exploring isn't actually what's important, but when you think about moving to industry, you need an energetic, charismatic manager. And that may be more important to you than programming, data, visualizations, and all of the other buzzword topics. And then you can go look for domain-specific problems. So you can jump on Kaggle, look around on LinkedIn. You can Google various problem statements, go on Wikipedia, and there's so many different sources of information that could illustrate what problems in a certain field may look like. And if you come for an interview and you've shown me that you've gone out and looked up the problem, you've had a go at it, you understand some of the jargon, and you can start to see that it's not just a test where there's a question and you fill out an answer, put a box around it, and present that to me as the final solution, but there's some nuance there that'll go a lot further to help change your ways of thinking. So what can you do to change your way of thinking to go from being a student to being a data analytics professional? The first thing I'm always going to recommend is sharing. So publish your code and documentation on GitHub and present to YouTube, include examples of what you're working on. If you're an instructor yourself, put up your lecture materials, etc. And you can do all these things together. So if you've written some code to do some data analysis, whether on Kaggle or on GitHub or wherever, and you can find some alternate code from someone else, a data analytics professional, a fellow student, etc., compare and contrast. And you can even make a video about, well, this is the way I wrote my code, this is why I wrote my code this way, this is what I see in this other person's code, and either I can change my code to be more like theirs because they have some really good ideas, or to say, we do things very differently, I prefer doing things this way, I can understand and respect what they're doing, but I prefer the strengths and weaknesses from my approach over theirs. So you can put it all together and try industry problems. So there are data on Kaggle, there are problems on Kaggle. You can get data through Quandl, and problems through, again, Kaggle, LinkedIn, corporate blogs, and finally just the job posting. If a job posting that you're considering applying for has a certain type of job, a certain type of requirement, like probability default models for a bank, say, if you can find some examples of that, and you can start working through and start to try to understand what the problems are and finding solutions for these things, which is why they need to hire you in the first place, you can show that independence so that if your boss doesn't really understand the details of what you're doing, that you are already engaged and a step up, and you are ready to independently take on these problems, and you're not expecting all the information to come to you as from a teacher, but you will take the initiative and solve problems that they need solved and get the job done. And finally, focus on fundamentals. While there's all this talk about R and Python, I use R myself, with AI and everything else, those aren't the tools I use in my day-to-day job. Most of the work I do is in regression, optimization, and linear algebra, and then exploring it all through Microsoft Office. So if you really get a firm understanding in those things, which I consider rather fundamental, if things get hard or things get compressed in terms of schedule, if you need to turn something out fast and share it with managers, using these tools will greatly aid you. Thank you for watching. This has been another episode of Real World Analytics, or What Schools Don't Teach You. I hope this helps guide you in different ways of thinking to be less of a student and more like a data analyst professional.